Very much for the introduction. So as the title says, this is actually a review paper which has presented an interesting challenge in preparing a presentation for a live audience. But what I've tried to do is focus on the high-level concepts that we've synthesized in the review paper rather than summarizing the various findings of the literature in this area. So hopefully there's some interesting takeaways and some concepts that might be useful. So there's been some interesting presentations in the session about aspects related or on interactive machine learning or related to interactive machine learning. The definition that we used in the review paper to help sort of guide us in finding literature relevant to this area is interactive machine learning is an interaction paradigm in which a user or user group refines a mathematical model to describe a concept through iterative cycles of input and review. So importantly here, we're thinking about the user as somebody who's a non-expert in machine learning, and they're doing things in an iterative fashion to slowly build up some sort of concept. Our motivation behind preparing this article was to try and understand the unique challenges specific to user interface design in IML and identify any potential research opportunities. So as we went through this process, we tried to identify the commonality across a very broad range of research in IML. As some of you are probably aware, over the past decade and a half, there's been great diversity in terms of the types of systems, or in terms of what the systems are trying to achieve, the kind of data that they're working on, and the machine learning techniques that are being applied within. So to highlight the commonality, in the paper we provide a structural and behavioural breakdown from an interface design perspective, and then we provide some general guiding principles for the user interface designer. And we hope that together these artifacts will help designers of these types of systems, not so much as a blueprint, but more as providing some structure to these underlying concepts. So I guess first of all, why do we care? We've seen some good, very interesting research in the IML space around improving workflows, so significantly reducing the effort in intensive processing tasks, such as involved in document review, so interesting work just before this presentation. Enhancing outcomes in analytic tasks by directly incorporating input from domain experts, such as in animal behavior monitoring, and dramatically extending the capability and creativity of users by supporting a form of pseudo-programming, so allowing people, non-experts to generate music and or other creative things like dance. The issue is that I guess in this space it is tempting to just grab at the latest and greatest machine learning technique and then shoehorn in some sort of interface to make it interactive. But I guess we argue that being more considered in this process is likely to further lower the barrier of entry for non-experts, so naive users who aren't familiar with machine learning, and to ultimately drive better outcomes. So also, most of the research in this area has been around quite specific one-off systems. If possible, the goal here is to try and move away from just a one-off system approach into some sort of system that might be generalizable across different application areas. So what are the key challenges in this area from an interface design perspective? We've seen a lot of interesting presentations at the conference so far around explainable AEI. Related to that is, how do you establish a productive dialogue between the user and the system? Within that, aspects of how you frame the feedback about the current state of the system, how do you capture input from the user, and how do you explain the decisions that the system is making to update its current state. And the second part there is, communicating the current state of the model overall, so in terms of representing the quality, the accuracy, but also practical things like knowing when to stop. So, can be a very difficult challenge to know if you're parameter tuning when to actually stop because you're no longer seeing any significant improvements. So what has been done so far in the space? Lots of great research, interesting things around supporting rich interaction, so allowing you to draw directly on an image to make image classifiers, or drawing components of a gesture and writing out the syntax to help build gesture recognition. Interesting work around explaining the results and the model state in intuitive fashions that are easy to understand for non-experts, and also providing teaching guidance to users as they're performing this iterative cycle. So trying to inform the users about what sort of feedback the system requires and how to help them maintain some sort of consistent concept over the exercise. So what main challenges remain then, despite this research from an interface design perspective? So obviously some of these are more general challenges that can be related to designing intelligent user faces in general, but how they specifically relate to interactive machine learning. So users can be imprecise and inconsistent, that's always a problem, but it's particularly problematic if you're trying to elucidate some concept and that concept is shifting in the mind of the user over time. Inferring user intent from user input. So as with any form of intelligent user interface, it is difficult to deal with discrepancies between user intent and user input. Interacting with a model is not like other more standard conventional interactions. So it can take many, many inputs, many, many cycles in the iteration before you see any significant change in the state of the model. And then it's difficult to constrain the whole process, and it's hard to give concrete guidance on when to stop this very open-ended process. So how did we try and I guess guide our thinking, or what have we done to try and help make some progress in the area? So I guess we started from a very top-down approach where we sort of created this very wishful vision for the future of IML, in which it's comprehensive in that it starts from the very point at which the person first thinks about a concept that they want to try and elucidate, right up into the point where they might be applying that or packaging it for some particular application. We assume a future state in which it might be collaborative, where there's lots of different users involved in the process, and then ultimately also that it's flexible in that it can handle different types of models and potentially be agnostic to many different types of data. Obviously, practically all these things present significant technical challenges, but it's useful from an interface design perspective to think about how, if we were able to build a system like this, what would it need to look like? So here we present our exceedingly simple structural breakdown with the flow of information illustrated. So the key components here, obviously the user, the data, the model, and the interface. And we drill down now into the interface component. So we suggest that an interactive machine learning interface may provide these 4 interface elements as part of the IML process. So we're not suggesting that these should necessarily be discrete and distinct windows in the interface, but rather that they reflect the tasks that the user needs to perform. And so decomposing them in this way helps give an impression of what kind of functionality needs to be delivered. So for example, I think, hopefully you agree, in Chisel, the ideas of reviewing the samples and assigning the feedback, that those two interfaces are combined into the same representation. So I guess I'm not arguing that this is a blueprint and that these are 4 discrete windows on a page, but rather that thinking about it in this way might help clarify what functionality needs to be provided. So I'm just going to go through each of these in sequence, identifying some of the challenges and some potential solutions suggested by the literature. So in terms of sample review, the sample review interface is the channel on which individual or collections of model outputs are presented for review by the user. Key challenges here are there's obviously a trade-off between requesting input versus pestering the user, so constantly asking them for input versus the system actually needs to get some input at times in order to improve its model. So requesting the feedback in a way that doesn't in turn introduce significant doubt in the mind of the user about the capability of the system. And then related to this is requesting feedback that the user themselves doesn't seem as totally irrelevant or not useful, so that it's going to have impacts on the way they engage with the system. Potential solutions here are supporting an assessment of the current state of the concept, understanding why particular samples have been presented for review, and avoiding overly abstract or condensed representations that take a long time to make some sort of assessment on. The feedback assignment interface is the channel employed by the user to assign labels, select features, and/or generate new samples. In this interface, this is the interface that perhaps requires the most careful design in terms of both the interface elements and the interaction techniques that need to be supported. So the challenges here are, you want to avoid overwhelming the users with knobs. People become obsessed with twiddling and focusing on checking what various things can do. But at the same time, you want to try and capture the high-level attributes that are inside, potentially the domain experts' knowledge. But that's difficult if you only have low-level features to work with. And then, as I mentioned earlier, this idea of concept shift. So over time, people's impressions of what they're trying to get out of this process can change. So potential solutions here are avoid constraining the labeling or demonstration process to the extent possible, and carefully framing the input request from the user. So the model inspection interface then is the summative view on model quality, so a way of getting a quick impression of how much coverage or how accurate the model is in its current state. Challenges here are understanding where error comes from and delivering an overview that actually gives a good summative impression of what's happening inside. Potential solutions here are highlighting those potential sources of error and providing methods that the user can use to test the current state of the model and where it might have inadequacies. So finally here in the task overview, what we're trying to represent by this particular interface is that there's guidance that might be independent of model quality, so related to how the user is progressing towards the task objectives and how that might be contextualized by things such as cost versus further effort in keeping on going in the task. So there's challenges here around identifying when you've reached a point where there's diminishing returns, and for other reasons, knowing when to stop. So here, it can be helpful to provide some guidance on what the global objectives are of the current task, and help to contextualize the other task considerations like effort, how much time has been spent, and those kind of things. Okay, so the second key contribution in the paper is the identification of this sort of standardized or common workflow. So this represents the 6 workflow activities in a comprehensive IML system of the future. It's intended to serve as a useful reference for designers as they consider the task transitions and distinct interactions that are relevant at each stage. So the model steering, the big circle in the middle is, I guess, where most research to date has been concentrated. Just briefly go through each of these. So there may be a need in the future to support feature selection and model selection as precursors to the model steering process. Then within model steering, this is where the actual iterative cycle of input and review is occurring. At certain times throughout this process, an interface switching to a stage of viewing and assessing the current quality of the model, and slightly paired with that is the idea of knowing when to terminate the process. And then ultimately taking what the concept that has been learned and applying it in some other application. Sometimes this may be as trivial as applying it onto a data set, or there may be no real distinction here. So finally, some emergent solution principles. So one, make task goals and constraints explicit. It's hard for the user to construct an effective feedback cycle if they don't really know what they're trying to achieve. So support understanding of model uncertainty and confidence. So help people to understand why something is fragile. 3, capture intent rather than input. Where possible, build the interface and interaction such that intent is captured rather than just input. So, I mean, obviously that can be difficult. Provide effective data representations. So to improve the process, help users get a quick overview of what currently is happening both at the sample and model level. 5, exploit interactivity and promote rich interactions. So try and maximally get as much information from users as possible, give them as much power as possible. And 6, make the task as engaging as possible so that they're motivated to push the quality of the model towards the desired state. So in conclusion, this article provides an overview of the main challenges involved in IML from an interface design perspective. We provide the structural and behavioural breakdown and a set of common guiding principles motivated by a broad assessment across the IML research. Thank you.
Great. Thanks, John. Let's thank the speaker. And we have some time for questions.
Gregorio Convertino, Google. I was wondering if you can speak a little bit about how did you derive your recommendations? So, I mean, what data, what examples you looked at? And for example, then a second question would be more what recommendation, beyond what would you say would be the next step for you, right? So could be identify, for example, UX patterns that would be derived from your guidelines, for example. So.
Yeah, so I guess in terms of the methodology, I guess what we tried to do is, so we just did a simple search term, looked at all of the literature that was returned based on interactive machine learning and the research that was then referenced by that. We focused on things related to user interface design and tried to pull out all of the common features from the papers in that area. That was the methodology that we tried to use. In terms of where next, I guess, I mean, our intent, I suppose, is more kind of sort of setting this potential vision for the future, or at least establishing some common language and some common concepts for this space. It would be an interesting, further avenue of research or trying to actually encode some of these ideas.
Okay, great. Another question?
So I was wondering if you've thought much about how interactive machine learning fits into a larger workflow, and depending on what the broader goal is, how that might affect some of the design decisions people have made for how they structure their interactive machine learning tools.
Yeah, that's an interesting question. So, yeah, I guess the way we've tried to approach it is the idea that it's this. We've tried to think about it as a very comprehensive system, but I totally get your point that you might have been doing some sort of analytics or data analysis to identify a problem that then you now want to try and train some concept to help with. I guess we haven't really considered the interplay between those potentially different tasks.
Okay, perhaps one final question.
Hi, Marlene Eiber, LMU Munich. I have to say I really liked your paper, and I was wondering, you presented these interface elements. Have you thought about how you would map them to more concrete interface elements? So they are naturally on a more abstract level, but have you thought about mapping them onto concreter elements?
Well, I guess within the article, where those, I mean, we didn't come up with those interface elements. I guess I would like to think that we looked at what people have done, and then we've just given them names or grouped them. So the paper does sort of, within those particular sections, lists a bunch of papers that have done some concrete work on actually implementing, interfaces along those principles.
Okay. Any more questions? I think I have one final question, because I work in this area. So if you were to give a bit of advice for anybody starting out looking at this, where is the most challenging gap, in your opinion?
Well, I think a very significant challenge is helping people understand uncertainty. So understanding both uncertainty at the sample level and at the model level. I think that's particularly important in interactive machine learning, given that we're focusing on people who are naive to machine learning techniques, and therefore, I mean, even many people who are familiar with them probably still struggle with this idea of uncertainty.
Okay, let's thank John.